In today's video, we're going to check out a new method to solve out quadratic expressions, which we call completing the square. And the reason we call this completing the square is because we're going to rewrite our expressions. So we actually do have a squared factor like an x plus 2 squared or an x minus 4 squared that would then let us solve that problem out a little easier. Another nice byproduct of this is when we do completing the square, we're actually changing an expression from our standard form that we can graph in, that you could plug into Desmos and get a picture out. We're going to be converting that over to our transformational or our vertex form that we can actually sketch out by hand. So there are definitely advantages of changing things over to that format. So let's look at a few problems where we're going to actually solve out using that method. And then we'll think about, well, what implications this has for actually changing stuff up so we can graph things in that form. So our first example, we're going to rewrite the expression y equals x cubed minus 14x plus 3 in vertex or transformational form. So we have some steps over here to the right to solve. The first thing that we want to always do is make sure that we've got everything on one side of the equation. And you'll see a little bit what I mean when we go to like solve this out. And actually our first set of examples, we're just going to be changing things over from standard to vertex form. So first scenario we need to do is actually group our two first terms. So we want to consider the x squared and the negative 14x. Now the way this is set up, I can't necessarily factor this out. And I definitely can't factor this particular example out. So I'm going to force this into a format so that I have my perfect square trinomial, AKA I've got something like x plus 2 or x plus 4 that I can square out. So we don't have any common a value. That would be our first thing to look at. Do we have an a term there? And we do not. So I don't need to actually take that first step that I have in the list. We'll look at a couple examples that do have that. So the next thing we have to do is figure out this term, b over 2 squared. And so you'll see why in a second why we pulled that kind of problem out. So in our equation, our b value is negative 14. That's whatever your coefficient is on your x term. And so I always like to kind of make some notes for myself over on the side. So for this, our b over 2 squared is actually negative 14 over 2. And if I simplify that out, I get a negative 7. But negative 7 squared, that's 49. So what I'm going to do to change up this equation is I'm actually going to rewrite it where I have a 49 in the mix. So this is going to look like x squared minus 14x plus 49. The problem is I just can't randomly add something into an equation. If I add that value in, I have to subtract it out somewhere else. So I still have that plus 3. I'm going to go ahead and subtract that 49, and that's going to even everything out. So if you add something and subtract it from that same side, those values cancel each other out. I'm changing what this looks like, not what any of the constants are actually worth. So then now I have this x squared minus 14x plus 49, and I can actually factor that out. So I know it starts with an x and an x. We have this 49, which I know is a perfect square because I did the math, 7 and 7. And I would need to use 2 negative signs to multiply to make that positive, but add to make that negative. So negative 7, negative 7. And I can go ahead and combine my like terms at this point. A positive 3 minus 49 would give me a negative 46. But then I can rewrite this a little bit more. We have an x minus 7 and an x minus 7. So I can actually rewrite that as x minus 7 squared minus 46. And now my expression is in that transformational, that vertex form that we used before. Now, just as a reminder, that looked like, y equals or f of x equals ax minus h squared plus k. Yeah, we don't have that a value in front other than an implied 1, but the expression is now in that format. So I could even graph this if I wanted to I know I would have to move my standard parabola that's sitting at the origin. I'd have to move it to the right 7 and then down 46 units. Definitely not something I can graph on a piece of paper, but I know where that would hit. So let's try another one. And again, this one, again, no a value to start out. It just starts out with an x squared. So we can just practice finding that b over 2 squared value. Alrighty, here we go. So again, I always look for, hey, do I have that a value? I don't. Implied 1, so I don't need to worry about that in this problem. I do, however, need to look at that b term. And I'm going to have to calculate b over 2 squared. And I always write this off in my margin because I don't want to forget what those values are. And I want to make sure if there are any negative signs that I'm dealing with those appropriately. So our b term for this one is 4. 4 over 2 squared, or 4 over 2 is just 2, and 2 squared is 4. So we're going to use those numbers when we rewrite things. So new format, again, group your first 2 terms and only your first 2 terms. I'm leaving that third constant off by itself. It'll get simplified in, it'll kind of get worked in later on. Okay, so then I need to balance or do my perfect square. And that's this b over 2 squared term that I'm going to use. So I'm going to add a 4 to the inside, which means I have to balance it out, subtract from the outside. So now I can rewrite my factoring. I'm actually going to skip a step on this one because I want you to notice something. This 2 that we have is the same 2 from this step. And actually, let's go back and look at the previous problem. Do we have that same thing happening? So previous problem, we had a -7 here, and that's the same -7 that ended up in our final problem. So by writing out that b over 2 squared, we're actually doing all the work for the problem all at one step. The only thing we're going to end up doing at the end is kind of balancing those constants that we have stuck at the end of the equation. And that's all there was to this problem. Okay, but what happens if we have an a term in that spot? So we've got to look at a couple examples for that. So let's check that out. Okay, example 6, rewrite f of x equals 2x squared minus 4x minus 20 in vertex form. This one has an extra piece of info. This one says, like all the rest of them were just state in vertex form. This one says now state the vertex and axis of symmetry. And again, the whole point of these kinds of problems is if I can take this equation, turn it into my vertex or transformational form, I can actually just read off the vertex and figure out what the axis of symmetry is without even touching the graph. So here we go. So I have to go back to that first step now. So I have this 2 sitting out front. I only want to factor the 2 out of those first 2 terms. So again, I'm not touching that -20 on the end right now. So here we go. If I factor out just the 2, so not a 2x, just the 2, that's going to leave me with x squared minus 2, and I haven't touched that -20 on the end. Oops, left out an x. Now that we have the x squared by itself, now it's time to do that b over 2 squared. So b over 2 squared. Now that we factored out that 2 from the a value, our b is now a -2. But -2 squared, or -2 divided by 2, is just a -1. And -1 squared is 1. So again, all this side work is going to tell me exactly what I need to do in my problem. Let me change my color. So this is what we're going to add and subtract. This is what we're going to actually have in our final factoring. Okay, so we need to be careful in this step. Here's why. So if I'm going to take that 1 and I'm going to add it on the inside, let me color code. Am I really just adding a 1? No. adding a 1 inside the parentheses, but the kicker is I've got this 2 out front. So when I'm trying to balance out my equation, subtract out what I added in, we're not really subtracting out just a 1. We are subtracting out a 2 times 1. And it's never a bad idea to completely write this step out, because then you can't lose track of what values you're doing. Whatever value you factored out in that very first step, you're subtracting out that number of, like, the 1s or whatever we added inside. The reason I didn't do this on the previous problem is because we didn't factor out an a value, so we didn't have to worry about it. Anytime you factor out the a value, be very careful to write out this step. Alrighty, so next piece is we're simplifying. And from here on out, again, most of the work is done for us. We already know what this is supposed to look like on our factoring. It's going to look like an x minus 1. And this piece, this -1 squared, that tells us what we have to use. So we've got a 2 times x minus 1 squared. Cool. However, now we need to simplify here. This 2 times 1, well, that's just a 2. And so I need to do -20 minus 2. So I'm looking at -22. And there is my final vertex form. So just looking at that equation, the same way that we did our transformations in the first unit, we can actually pick out our vertex. This expression had to move to the right 1 because of the -1. And down 22 because of the -22. And then new from the beginning of this unit, our axis of symmetry, that's just our x value from our vertex. So that's just x equals 1. And again, if you wanted to verify this, feel free to pause the video, go plug this new vertex form equation into Desmos and see if that's true. See if you have your vertex at the point 1, -22. All right, let's try another one. And so actually this is, I believe, the last, nope, we have 2 more examples. Okay, now would probably be a good time almost to try out example 7 on your own, but you might notice he looks a little different from the previous one. Now, if we're starting, all of our previous problems started with the x squared term, the first thing we want to do is actually move things around. So I'm going to rewrite this so it looks like ax squared plus bx plus c. I have to pull this -3, or I have to pull the negative with that x squared. 24 was already an implied positive, and the negative stays with the 50. Okay, here we go. We need to look at our b/2 squared, but we can't do that yet. What do we have to do first? We need to see if we can factor out an a value. And so then on this, if we do that in that first grouping, we'll have a -3 that we can actually factor out. If I take that out, that gives me an x squared. Don't forget your signs. Dividing out that -3 will give me a -8x. And then we have the -50. Now we're ready to do b/2 squared. So b/2. Our b value is now -8, which simplifies out to a -4. And -4 squared is 16. And so that's that 16 that we're going to add and subtract to balance things out. So we have a -3, x squared minus 8x. Come on, here we go. Add your 16 inside. But then we have to subtract our 16 outside, but we're not really doing a 16. Let me color code. We're really subtracting out a -3 times 16. Because don't forget that a value, it's still influencing that anything that's inside those set of parentheses. Alrighty. So we're pretty much just simplifying from here on out. And this -4 tells me exactly how I'm going to factor. -3 x minus 4 all squared. Okay, then I need to simplify. Well, negative 3 times 16, what does that come out to? So that gives us a negative 48. And then I have a negative 50 minus a negative 48. This is why I write everything down so I don't lose track of my negatives. So that's really plus a positive 48. So that's going to come out to a negative 2. That whole expression came down to a very straightforward quadratic function equation. And again, once it's in that format, we can just read off our info. So our vertex is going to be at the point 4, negative 2, because we would have had to move to the right 2 and or the right 4 and down 2. And then our axis of symmetry, which you might sometimes see me abbreviate like this so I don't have to write everything all out, is always going to be that x value from your vertex. So that's x equals 4. Alrighty, now would be a good time to go ahead, pause the video, and try out example 8 on your own, then restart it, see how you did. Okay, so let's see how example 8 went for you. So and just like the previous one, again, everything's in order, so I don't have to rearrange, but I do need to consider my first 2 terms, and I've got that a value to factor out. So this is going to be factoring out that negative 4. Again, don't take the x with it. Just the negative 4, that'll give me an x squared minus 6x, negative 36 sitting on the end by himself. B over 2 squared is going to be a negative 6 over 2 squared, aka negative 3. And negative 3 squared is 9. So add and subtract are 9. That'll give me a negative 4. X squared minus 6x plus 9 minus 36 minus or 9, but times our a value, so that's negative 4 times 9. Okay, then we're ready to simplify things out. Let's see, I'm going to go ahead and simplify this guy out. Negative 4 times 9 is going to give me a negative 36. And then I'm ready to write my last step. So again, negative 6x in the middle, positive 9. Everything would come out to an x minus 3 squared. And this one actually works out really nice for us. We have a negative 36 minus a negative 36, which really means we're doing plus a positive. And wait a second, negative 36 plus 36, that means the whole thing just cancels out and we're just at negative 4x minus 3 squared. So technically what that tells me is I could have, if I wanted to, just factored out this equation and still gotten to the same answer. And so that's something that you'll need to choose. There will be some problems where we might not tell you which method to use to solve out. Now, those are not going to be very often, but as you get higher and higher in mathematics, and maybe even towards the end of the next unit, when we're going to add in even one more solving method that we'll look at in Unit 5, it might be important to choose, okay, which method do I want to use to solve this out? Again, just reading off my info, we have our vertex is going to be at, you had to go right 3, but there's nothing to say if it moves up or down, so it's just at 0. And our axis of symmetry would be x equals 3. So we can also solve using, or solve non-factorable expressions by using completing the square. So let's look at example 3. Before I start this, I actually want to make sure that I have everything on one side of the equation. So let's move everything over, which really just means moving the 5. So we have an x squared plus 4x minus 5 equals 0. We don't have to worry about dividing out that a value, so we can jump right into figuring out our b over 2 squared. Our b value is 4, and 4 divided by 2 is 2. 2 squared equals 4. So this 4, again, that's what we want to add and subtract to balance out this expression. So I'm going to add that inside the parentheses and subtract it outside the parentheses. So keep in mind this positive 2 in here. That tells us what we need to use to factor. So we can factor this as x plus 2 squared, and then simplify our -5 minus 4, which would give us a -9 equals 0. So now, to solve this out, we want to actually isolate our set of parentheses. We want to isolate that x plus 2. So if we move the 9 over, that would do that. So x plus 2 squared equals 9. And now the only thing that we need to get rid of is that squared. So let's take the square root of both sides. That leaves us with x plus 2 on the left. And on the right, we have square root of 9. Now, keep in mind when you're dealing with square roots, you actually have two possible answers. I could square a positive 3 to make a 9, and I could square a -3 to make a 9. So we have to take both of those into account. So we have positive and -3 as a solution for square root of 9. So that means we really have to consider two possible answers. One that we'll get when we set x equals 2 equal to positive 3, and one when we set x plus 2 equal to -3. So then solve each one. So subtract a 2 from both sides. So that means we have two solutions on this, that x is either 1 or -5. And again, sometimes this works out really well that we have the perfect square, but sometimes not so much. So let's check out example 4. So in example 4, we do have a leading a term. So we need to go ahead and factor that out of both our two first terms in the expression. So factor out our -2, again, just the -2, so we're not factoring any x's out. And we always leave that third term on its own. So now we need to go through and find our b over 2 squared. Now that we factored out that -2, our b value is a -2. But -2 divided by 2 is a -1, and -1 squared is just 1. So we are going to add the 1 inside the parentheses, but we're going to subtract a -2 times 1. Again, when we add the 1 inside the parentheses, we're not just really adding a 1. We have to consider that a value that we factored out at the beginning. So now we can start going through and simplifying. Again, this -1 tells us what we can do when we rewrite our first kind of piece of this in factored form if we factor out that x squared minus 2x plus 1. Let's see, we know -2 times 1 is just a -2. And so to simplify, positive 6 minus -2 would actually give us a positive 8. Okay, then we're in the same boat as we were before. We need to isolate that x minus 1 squared. So first thing I would do is subtract an 8 from both sides. And then I would divide both sides by 2. So that's going to give us, or -2. That will give us x minus 1 squared equals 4. And actually, this one's going to work out really nicely too. So keep in mind, sometimes we might have some square roots happening here. If that's the case, when we go through and we take the square root of both sides, we would just leave that as a square root. So let's say instead of the 4 here, we had like a 21. When we take the square root, we would just leave it as a plus or minus square root. So we don't have to worry about simplifying that in decimals, but that might pop up every so often. Alrighty, so two versions. X minus 1 equals a positive 2, and x minus 1 equals a -2. Move your 1 to both sides, so x equals a positive 3. And then same thing on the other expression. That's going to give us a -1 though, -2 plus 1. So our two solutions on this will end up being 3 and -1. Again, if you need more examples on these, you want to try these out maybe with not having that perfect, number that takes a square root, definitely let me know. But we're going to go over this again. I think we're going to do another practice problem as our warm-up for next class. So do let me know if you have any questions.